There are at least two additional ways we can analyze these dissociative identity disorder data in the OM software. And again, we're doing so instead of running a traditional between subjects analysis of variance. Now, I will place links for those two previous videos where I've analyzed these data and talked about these data in the description below. You can check those videos out. But let's go ahead and switch over to the software and again, see two additional ways we can analyze these data. So let's remind ourselves quickly how we analyzed the data in the previous video. So there we selected analyses, build test model, and build our model and ran the analysis. Again, this is one way you can analyze these types of data instead of using a between subjects ANOVA. Now let's take a look at another way. So I'm going to cancel here and let's go to analyses and pattern analysis, and we're going to cross the orderings. So here is our grouping ordering. I'll double click it and move it over. Here's the recognition ordering. I'll double click that and it moves over to the second ordering. Again, you can move things back and forth using these arrows as well. Now we need to define the pattern. So I'll select that and I'm going to magnify this a little bit so we can see what's going on. So notice we have the 4 groups down the sides comprising the rows, and then we have the 0 to 15 possible recognized words across the top comprising the columns. Now, the goal here is to tell the software, tell the program where we think the data are going to be located. Now, this is a difficult task. You're going to need some serious theory to figure this out. So it looks simple on paper, but it is difficult in practice. So for example, where do we think the controls are going to be located? What numbers of recognized words do we think we're going to see? For example, do we think it's 8 to 15? Is that the case? Then perhaps for the DID patients, 0 to 2. And then maybe for the simulators, it's 0 to 2 as well. And then maybe for the guessers, we see or expect the observations to be located here. So it looks simple on paper, but it's difficult in practice to pull this off because you're going to have to defend whatever you do here to your readers. And if you've got a strong causal or integrated model to back you up, that's going to make things a lot easier. Now, if you wish to do this in an entirely ad hoc fashion, we could select all observations. And here are the observations. And so perhaps we're going to switch the DID patients to only showing up with 3 recognized words. And then perhaps we'll just remove the overlap, although it's not necessary for the guessers here. And so perhaps this is the pattern that we wish to test. So we go ahead and select OK. And what the analysis is going to do is just count up the number of people in those green cells. And that's going to be your % correct classifications index. Go ahead and turn on the randomization test here, select OK, iterates through. Here is the pattern that we just evaluated. Here is the % correct classifications index, 72.34, seems like a respectable result, and the chance value is less than 0.001. Now, we could also run this type of analysis if we wanted to compare just specific pairs of groups. So as we did in the previous video, perhaps we can compare the DID with the simulators. We would just set that ordering up and then go through this process and define the pattern just for those 2 groups. So this is one way to analyze the data, or another way I should say, in addition to the build test model. Now let's check out a third way. So here we can go to analyses and now ordinal analysis, and we're going to cross the orderings again. Now notice here the second ordering is your grouping ordering. So we're going to put the group over there, and then the recognition we're going to put into the first ordering. Now let's define the pattern. And here what we're doing is setting up an ordinal hypothesis or ordinal hypotheses. So notice that the rows are labeled highest to lowest, and then we have the 4 groups across the top. So which of these 4 groups do we think is going to recognize the most number of words? Well, it seems reasonable to select the controls there. Now, after the controls, who's going to recognize the second most number of words? Perhaps that's going to be the guessers. And then perhaps we'll put the DID third, and then perhaps the simulators last, expecting that perhaps again they will overdo it in terms of the amnesia from one personality to the next. So again, this is an ordinal pattern that we're setting up here, a set of ordinal hypotheses. So let's go ahead and select OK to accept the pattern. Let's turn on the randomization test and select OK to run it. All right, it iterates through. Let's actually start at the bottom here of the output because I think things will be most clear here. So notice this is labeled pairwise ordinal results. So notice the first row here, the DID patients were expected to be lower in terms of the number of recognized words than the controls. So what the analysis does is it takes all 19 individuals in the DID group and compares their recognition scores to all of the individuals in the control group. So again, imagine taking the first DID patient, compare that person's recognition score to every other individual in the control group. And is it the case that that DID score is lower than the control scores? So we do that for all possible combinations of individuals in those two groups. So that turns out to be 475 pairs of observations compared. And in this case, all 475 met expectation or matched this ordinal pattern here. The control individual was higher than the DID patient in every instance. And if you recall the multigram from the previous video, that was clearly the case. All of the control individuals recognize more words than all of the DID individuals. So that gives us a PCC then of 100%. And not surprising, the chance value is 0.00 or less. Then we see the second row. It's the DID patients expected to be greater than the simulators. Again, 19 and 25 individuals in those groups compared 2 at a time, 475 comparisons. That's 306 that were correctly classified or met that ordinal pattern. And so that gives us a PCC of 64.42%. And the chance value is 0.02. And then you can see the other pairwise comparisons here. So all possible pairwise comparisons here from that ordinal pattern that we set up are being tested. Now, if we scroll up, we can remind ourselves of the pattern. So here we see it again. Now, if you add up all of the numbers in these two columns, you're going to arrive at 3,300 classifiable pairs of observations. Of those, 2,872 were correctly classified or met the particular ordinal classification or ordinal expectation, I should say. And so that is a very high PCC index of 87.03%. And then the chance value, not surprisingly, is less than 0.001. So this is another way we can analyze the data instead of running a traditional analysis of variance.